Imagine you have the biggest and smartest AI model ever built. It has almost 671 billion parameters. At once, when you ask a question, it only loads 37 billion parameters. Then you think, okay, I can load it in my laptop, but you are wrong there. And let's figure out why you are wrong and why this model requires a handful of servers just to load this model. The imaginary model that I was talking about is not imaginary anymore. It is DeepSeek V3, an actual model which requires two sets of parameters. The first one is 37 billion parameters. It is a number of parameters that it requires to answer your question. And the second one is the total number of parameters the total model holds in its memory. So these two numbers does a completely different job. The one is about speed, the other one is about the size. And mixing them up is where the whole story actually tends to begin. Now picture a giant hospital with 256 doctors inside. Each one studied something very different. A patient walks in. Think of that patient as one word going through the AI. The hospital doesn't take all the 256 doctors to attend this particular patient. It only calls the 8 most likely to help. That's our 37 billion parameters from the model. Sounds smarter, fewer doctors, less cost. But that doesn't mean that you cannot send off the rest of the doctors, because the next patient or the next token coming in might need the completely different set of doctors altogether. So nobody knows which doctor will be needed until the actual token comes into the picture. So all of the 256 doctors have to stay at the hospital all the time, ready and waiting for the patient coming in. That's why the memory never shrinks. Easy switch has to be there just in case. Now let's look at the model that we are discussing about. It has 671 billion parameters. Each of these parameters is 2 bytes. So totally this adds up to 1.3 trillion bytes. That is almost 1.3 terabyte. A normal hard disk a normal GPU or normal graphics card holds almost 80 billion. 1.3 trillion versus 80 billion. That's why this cannot live in a single machine. It never does. So the 256 doctors get split up across 8 different buildings, 32 doctors per building. A patient walks into the building 1, their home building, but their target doctors could be anywhere. Some in building 1, some in 5, some in 8. So the patient's entire file has to be driven across the city to every building with one of their doctors. Then once each doctor finishes, the node driven back to the building 1, so the final reports comes together. Now do that for every patient, every layer, thousands of times a second. That driving across the city has a name, all-to-all communication. And it doesn't happen at once, it happens again, every layer the AI has. Strip away the hospital and here is what that actually looks like inside the real machine. Let's do the ugly math. 256 doctors, 8 buildings, 32 in your home building. A patient needs 8 doctors. So here is the question. In the worst case scenario, how many of those 8 doctors are outside your home building? It could be all 8. The hospital does not care where you walked in. It only cares who's the best for you. So every layer, every word, it might drive your file to 7 other buildings, drive the results all the way back. And here is the part that really got me. This is in the unlucky case. With 256 doctors and only 32 at home, you would expect on an average just one of the 8 doctors available at the home where you are reached. 7 of the 8 leaving every layer, every word. That's the tax. Someone says just send more patients at once. Big trucks beat small trucks. That's actually how normal AI model works. Load one set of doctors not once, then reuse it for 100 patients in a row. More patients per trip. Each trip worth more. This hospital is different. Every patient carries their own file, needs their own trip to their own doctor. Then more patients and you don't get more value per trip. You just need more trips. More patient needs means more computing and more driving. Both go up together. The trucks never get more efficient. You just get more of them stuck in the same track. The another idea will be to shrink the doctor's notes, make them tiny, and the driving problem disappears. This is quantization, and yes, it really does shrink things. But shrink what? It shrinks the notes on the shelf. It does not shrink the patient's file while it's traveling. That still needs to stay near full size, or things get scrambled on the way. And even if you squeeze all 256 doctors into 2 buildings instead of 8, you still have 2 buildings, still have the driving. The only way to make the driving disappear completely is to fit every single doctor into 1 building. For a hospital this size, it's not realistic. Quantization makes the tax smaller, it does not make the tax go away. So, if you cannot stop the driving, what do? You build faster roads. That's a real story behind the giant new computer racks you might have heard about. Built to connect mini GPU with super fast links. Their selling point is not making the doctors do things faster, it's making the road between the buildings so fast it feels like no distance at all. Compute was never really the hard part here, the road was. Let's not just take my word for it. Grab a pen or 2 boxes, 4 doctors in each, 8 total. Draw 6 patients walking into the box 1. For each one, pick 2 doctors at random out of the 8. Draw lines. Every time a doctor's in box 2, the line crosses. Go on. Count your own lines. I did this myself. Almost every patient has at least 1 line crossing over. That's the moment this stopped being a sentence in a report and became something I could actually see. Here is what I got wrong at first. Fewer active switches, I thought that meant a smaller, cheaper model. It does not. A bigger batch, I thought that always helps, but not here. Quantization, I thought it solved everything. It only helps a little. Here is a real lesson. This kind of AI didn't get cheaper, it got rearranged. The course moved from math to the road. So here is the bigger question, and nobody's fully answered it yet. As these AI brains keep growing, do we need the building faster roads forever? Or is there a wall, a point where the driving itself comes the ceiling? No matter how many switches we add, I don't know yet, but now you can see the traffic.